We're going to be talking about line segments today. A line segment is defined as a straight line connecting two endpoints. There are 5 important characteristics of line segments that we will explore: length, midpoint, slope, domain, and range. Length will be our first focus. The length of a line segment, what we are going to do is we're going to use trigonometry to find the length. The length is calculated by using Pythagorean theorem by creating a right angle where the line segment itself and the hypotenuse, and the two legs are perpendicular to the x and y axis, both perpendicular and parallel. Let's just see what we mean here. Let's get started. So I'm going to call the first point A, and A is going to be right here. A is going to have coordinates 1, 2. B will be here. B is going to have coordinates 5, 5. My line segment AB goes from A to B, and sometimes it's written as line segment AB. So what is the length from A to B? Or another way of looking at it is, what is the length of line segment AB? It's very difficult to determine because it goes diagonally across the coordinate system. So what do? Well, we create a sides of the line segments, and we start off at point A and we move horizontally towards B. And then we move upwards once we get to the correct x-coordinate that B is, and we just simply move up. The intersection of these two sides of the triangle will always form a right-angled triangle. And then, very simply, I can ask myself, how long is the horizontal or the pink side of this triangle? Well, it's 1, 2, 3, 4. It's 4 wide. How tall is this triangle, or what is the length of the blue? It's 1, 2, 3. Now, I would like you maybe to start to challenge you the x-coordinate of A and B. So if we start off with A and move to B, we went from 1 to 5. How far did we travel? 4. Positive 4. Now, the y-coordinate of A was 2, but we went to 5. How far did we travel? Well, 3. So, now let us calculate this. What we see is we have a right angled triangle, and the hypotenuse is indeed the line segment itself. So we just need to calculate the length of the hypotenuse in order to get the length of the line segment. Recall that using or Pythagorean theorem says the hypotenuse squared is equal to the sum of the sides squared, the other side squared. In other words, c squared is equal to a squared plus b squared. So c squared is equal to, if I take 4 and I need to square that, plus 3, I'm going to square that. So c squared is going to be equal to, I'm going to try to simplify the right-hand side. I'm going to carry out the operations of exponents first. 4 squared is 16. 3 squared is 9. So c squared is going to be equal to 25. What we may choose to do now, how do we solve for c? Well, you simply take the square root of both sides. So therefore, c is going to be equal to plus or minus 5. C can be equal to minus 5 or plus 5. But in the context of distance, we only have positive distances. So that whole notion of positive and negative will come in later. Moving on, example number 2. Determine the length of a line segment with endpoints -2, 7, and -6, -3. So I'm going to call one A and one B again to help me out. -2, 7. There we are. There's A, and I like to write down my coordinates sometimes, so I'm just going to write that down, -2, 7. B is -6, -3. So there's B. What I would like to do is calculate the length of this line segment. All right. So again, I'm going to draw a horizontal line from A that is parallel to the x-axis, and now I can draw a vertical line that is parallel to the y-axis. This makes a right-angled triangle. Again, I could ask myself, well, what is the length of the bottom of my triangle? So I can say 1, 2, 3, 4. So here, it's 4. Now the height of this triangle is 1, 2, 3, 4. It's 4. So the length, AB, is going to be 4 squared, pardon me, I made this mistake. Perhaps I would want to write it as C squared is equal to A squared plus B squared. And what I notice is that both sides, the non-hypotenuse sides, are going to be 4 here. And just to double check, going from the x-coordinate of A, -2, to 6, I moved 4 units in the negative direction. Going from 7 to -3, I moved up 4 units. So that's how I get the base and height if I want. Later on that will come in handy. So C squared is going to be equal to 16 plus 16. Now C squared is going to be equal to 32. Therefore, C squared is equal to 32. Maybe that was a little bit too early for a conclusion. I'm going to take the square root of both sides, and what I get is C is equal to the square root of 32. Now, this is one answer to it, and it may be a little bit incomplete. So I'm going to write this in rational form. What I can do is I could rewrite the square root of 32 as 2. Sorry, that's incorrect. Maybe I'll do this in my calculator first. Square root of 32 is going to be 5.657 to 3 decimal places. Now, if you're trying to get extra fancy on me and you have a little bit more skill in math, we'll be learning how to do this later. So this is what is known as an approximation. If I wish to write this in irrational form, I can choose to write it as 6 is equal to 16 times 2. That is, I identify the perfect square factor of 32, and that's 16. So therefore, C is going to be equal to the square root of, I'm going to split this up now, 16 times the square root of 2. And this simplifies into C is equal to 4 square root 2. Now, surely this is an advanced form, but we'll be going to this direction later on this year. Perhaps you even have the skills to do this at the moment.